Welcome back to Integral Calculus. In this video, I have a couple of tricks, a couple of ways to think outside the box when using integration by parts. Nothing new here, just a little bit of, as I said, trickery. So let me get my head out of the way and we will dive right in. The integral of the natural log of x. I think this immediately shows why I said this is trickery, because that's only one function. There's not two things multiplied together here. But of course, mathematicians' favorite trick is to just introduce something where there was nothing. So I could call this 1 times the natural log of x. Now it's two things multiplied together. That counts, right? Well, it's true lazy people ride the elevator. Logarithms before polynomials, and 1 is a polynomial. So if I was going to do integration by parts on this, I would set u equal the natural log of x, and dv would be 1 dx. Okay, well in that case then du would be 1 over, that's not an x, 1 over x dx, and v itself would be x. So I need u times v, x times natural log of x, minus the integral of v du, x times 1 over x dx. Add in our constant of integration, and the integral of the natural log of x is x times the natural log of x minus x plus your constant of integration. Now that you see it, it's fairly straightforward. There's nothing new here, but realizing that you can do integration by parts in the first place is not easy. Integral of e to the x sine x dx. This one feels like it just falls into the same category of what we've been doing. But once you start into this, you're going to realize things are going to go sour. Right? It's true lazy people ride the elevator, trig before exponentials. So I'll let u equal sine x, and then dv is going to be e to the x dx. Which means that du is going to be cosine x dx, and v is just going to be e to the x. So I've got u times v, e to the x sine x, minus integral v du, e to the x cosine x dx. And okay, we've seen this fish before. The integral we're left with after we integrate by parts is two different functions multiplied together, so we should probably integrate by parts. I guess u is going to be cosine of x, dv is going to be e to the x dx, and from that I get that du is the negative of sine x dx, and v is just e to the x. So my e to the x sine x stays in front. Then I have minus u times v. It's going to be e to the x cosine x. And then minus is going to be plus the integral of v du. Of course, there's a minus in there, so I guess we're back to minus out here. And it's going to be e to the x sine x dx. No, that can't be right. I started off with the integral e to the x sine x. I got a mess minus that same integral we started with. But if you stop and think about it, you can really have some fun at this point. What did we just do? We said that the integral of e to the x times sine x dx is equal to e to the x sine x minus e to the x cosine x minus the integral of e to the x sine x dx. What if I rearrange this equation? Yes, seriously. I'm going to take this integral and move it onto the other side of the equation so that I have the integral of e to the x sine x dx plus the integral of e to the x sine x dx is equal to e to the x sine x minus e to the x cosine x. And at this point, I realized that there might be a constant of integration involved here somewhere because there's no integrals left on the right-hand side. So I guess I should probably fill that in just for safety. It might be that c is 0, but that'll give me some safety. And then over here on the left-hand side, I have the same integral twice. That's just 2 times the integral e to the x sine x dx. And so if I divide both sides of the equation by 2, I get a result. No, that can't be right, can it? Can it? This is, to me, one of the most amazing results. I never would have believed it if, well, first of all, I read it in the textbook when I was a student. Then I went to my instructor and said, no, this can't be right. And my instructor said, yeah, no, that's how it works. And then he told me, well, why don't you check it? Remember, the integral is the inverse of the derivative. So take the derivative of the thing my body is covering, 1/2 e to the x sine x minus 1/2 e to the x cosine x. See if you end up with e to the x times sine of x. And what do you know? I did. So yeah, it works. It feels wrong, but it works. This is a relatively short video because I think the impact of that is probably going to have you sitting and staring for a little bit before you try one on your own. I want you to look at the integral of secant cubed of x. And I will give you the hint that the first thing you want to do is rewrite this so it looks like the product of two functions. Secant x times secant squared x. From there, it's integration by parts. It's going to be messy. It's going to take a while. This is one of the longer sign problems that I'm going to give you in this course, but that's what you get when the video itself is this short. Take a few minutes, see what you can do with that one, and I'll see you in the next video.